We're going to take some time to go over the tangent function now. Hopefully you have a good understanding of what the sine and cosine functions look like, because we're going to kind of use those ideas to help us graph the tangent function. So we get a couple of tangent values into our table here. They're going to help us graph. So remember, tangent, a couple things that are, actually, we'll put this right on the notes here. A couple things to remember is tangent is sine over cosine. So where cosine equals 0, tangent is going to be undefined. So anywhere that we have cosine equaling 0, we're going to have asymptotes on our tangent graph. Okay, let's think about where cosine equals 0 on our unit circle. I'm actually going to move this down here, so I have some space in my graph. If you think of where cosine equals 0 on our unit circle, cosine is going to equal 0 right there, pi over 2, and right here at 3 pi over 2. So at pi over 2 and 3 pi over 2, so here's pi over 2, tangent's undefined, and instead of doing 3 pi over 2, I did a negative pi over 2 here, same thing, they're coterminal. Then tangent is also undefined right there. Okay, and then where sine equals 0, tangent will equal 0, because you're going to be taking 0 divided by a value. So where sine equals 0, tangent equals 0. So sine equals 0 at 0 and pi. So we know that tangent is going to equal 0 at 0. And then the other values we have are pi over 4 and negative pi over 4. Well, the tangent of pi over 4 is 1. That's off of our trig table. And the tangent of negative pi over 4, okay, negative pi over 4 is right there. Tangent is negative in the fourth quadrant. So it's going to be negative. And then the reference angle is pi over 4. We know that the tangent of pi over 4 is 1. So the tangent of negative pi over 4 is going to equal negative 1. So if we keep these ideas in mind, I'm going to start making my little graph here. This is going to be pi over 4, and this is going to be negative pi over 4. We're going to make this right now 1 and this negative 1. So this would be obviously 0 at the origin. This asymptote there, I'm going to actually put it right down here as pi over 2, and this is negative pi over 2 because tangent is undefined there. So really the only values that we have to plot here are that the tangent of 0 is 0, and the tangent of pi over 4 is 1, and the tangent of negative pi over 4 is negative 1. And then this graph is going to look like this. It's going to use those asymptotes and go up and down those asymptotes, and it's going to go through the origin and cross through the points pi over 4, 1, and negative pi over 4, negative 1. And that is what the basic graph of tangent looks like. Just like sine and cosine, we're going to have a and b values that are going to affect the graph. It's going to come right down here. That when we have this a and b value in here, it's going to affect the graph of tangent. Actually, before I talk about that, let's talk about what the period of the tangent graph is. This would be one period or one cycle of the graph, whose length is called a period. From negative pi over 2 to pi over 2 is pi. That's the period of the tangent graph. Unless you have a b value there. Then what we're going to do is have pi over the absolute value of b as our period. The function is going to have asymptotes at, instead of always pi over 2 and negative pi over 2 the way that it was up here, if you have a b value in your function, it's going to affect those asymptotes. We're going to have asymptotes at pi over 2 times the absolute value of b, since tangent is undefined at those values. The x-intercept is going to be 0, 0. And then the 5 key points in one cycle are the 2 asymptotes, the x-intercept, or once we start shifting up and down the midline intercept. And then the two turning points that are halfway between the x-intercept and the asymptotes. In our graph that we just did, those halfway points happen at pi over 4 and at negative pi over 4. What we're going to do is stretch this graph out using a. So in our function up here, a was 1, and that's why we have a 1 right there and a negative 1 right there, because a equaled 1 in that graph. Okay, so if you have a value that's not 1, I'm just going to do a quick sketch here. We're going to have our graph get stretched out to a and negative a halfway to the asymptote. So if this is our first asymptote here and this is our other asymptote over here, then halfway to those asymptotes, and we can even put this here, we know that this is going to be pi over 2 times the absolute value of b. So this would actually be pi over 4 times the absolute value of b. I think it's getting pretty detailed there if we put that. Just know whatever this is, you got to go half of it. That's that value right there. You're going to go up to a and then down to negative a. So cross through that x-axis or through the origin. And then here's our other asymptote here on the other side. It's symmetric over the y-axis. And so this is what our tangent graph is going to look like. Kind of looks like a cubed function, because it is an odd function like the cubed function. Okay. This graph here is just meant to show how this continues on forever and ever, just like the sine and cosine graph continued like those periodic functions forever and ever. Tangent is going to continue on going through these points. So this is the one that we drew up above, okay, with this being pi over 4 and negative pi over 4, 1, negative 1. This was our first asymptote, pi over 2. This is the one to the left of the y-axis at negative pi over 2. But this would continue at all odd multiples of pi over 2. We would have an asymptote. And it even says right there, odd multiples of pi over 2. And obviously, if there's a b value involved, you'd have to take that into account. And then I'm not going to get too crazy here. I'm not going to label the x-axis. I'm just going to throw these other points that are in here. So you always go through the x-axis, and then halfway to the asymptotes, you go down and up. In this case, we're just going to 1 and negative 1 because of the a value being 1 there. So these would all just look like this. And these cycles repeat over and over and over again. I don't have my asymptote here. But if I did, it'd be about right there, and this would continue up that asymptote. So that is what the graph of the tangent function looks like. I'm going to go right away to the example sheets that we have and look at what a tangent graph would look like on there with different values other than 1 for A and 1 for B. So in this case here, we have an A value of 3/2, which is going to stretch it out 1.5 times, and our B value is 4. Okay, so the first thing that you should do is use that B value to find your period. Period then is going to be pi, not 2 pi, that's sine and cosine. Oops, I did it again. Pi over 2 times the absolute value of B. So our period is going to be, no, excuse me, let me just write this here. Period is pi over the absolute value of B for tangent. Okay, so the absolute value of 4 is just 4. That's your period. I was starting to talk about asymptotes already. So if that's your period, and you know that your asymptotes are going to be at pi over 8 and negative pi over 8.
Good morning. Just a quick announcement to remind students that our voice back.
All right, so these are the asymptotes of this tangent graph, pi over 8, negative pi over 8. And so what I'm going to do is come over to our graph here, and I'm just going to go out an even number of, I'll go with 6. I'll go 6 values and say that this is pi over 8. And 2, 3, 4, 5, 6. This is negative pi over 8. And that is where our asymptote should be. And the reason why I just picked an even value for that is because halfway to that value, I want to be able to identify what this x value is there, because that's going to be my turning point. So half of pi over 8 is pi over 16. So these are the two values that we're going to be turning this graph at. The a value here is 3/2. So this is going to be hard to get this one to scale. I get that, because pi over 8 is a pretty small value, and we've already said it's that far away, and 3/2 is not that it's a large value, but compared to pi over 8 it is. So I'm going to try to put that 3/2 kind of high on this, but not too high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I put a 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here is negative 3/2. Just so I can see the turn in this thing. So I pretty much know right now this is not to scale. This is going to cross through the origin, and then halfway to the asymptote at that pi over 16, it goes up to 3/2, and halfway back, it goes down to the negative 3/2. And I'm going to be able to graph this in as such. So you're going to go through those 3 points and then use the asymptotes to finish the graph. That is what our tangent graph is going to look like. All right, so if we take a look at, actually I'm going to put a new video up. I think video number 4 would be doing examples of shifting these functions the way that they are done on the back side of this example sheet. We'll probably do those notes and examples together in one video.